electric current effects.
Okay, ma'am.
I'll be revising the chapter first of all. I think that chapter was done by me or not. Okay, turn on your video. Let me first of all revise that chapter. Okay, so electric current and effects in this whole chapter we'll be learning about how to make a cell, how to form a cell, when does the cell actually, just 1 minute, I think this So how does we form a battery, how it will be making a connection and all, what are good insulator, conductor, all those things we'll be learning. Closed circuit, open circuit, and other things as well. So let us start with the chapter. I am not going to go very deep into the chapter because already I've studied this chapter. I'll be just giving quick revision of the chapter. So when we talk about the electric current, basically we also talk about the electricity, right? So electricity, how do we get? In the form of the electric current. And electricity is a what? It's a form of energy. Like we have a light, which is a form of energy. Same way, electricity is also a form of energy. And through which what we will be getting? We will be getting the light that can be converted into light, sound, or heat. So if we have the electricity, then definitely we can, we can use the tape recorder, we can use the other music system, we can use a DJ. But if we don't have the electricity, then definitely we cannot use them. Same way, with the help of electricity, we will be able to switch on the gauger, water gauger, or any other appliances. Like with the help of electricity only, we will be able to do it. And electricity will be working when we have the light. So both the things are like correlated to each other. So electric is generated due to movement of electric charge. So why this happens? It happens because of the movement of the electric charges. So we have two charges. One is positive charge and the other one is the negative charges from the sources. So the sources of electric current are cells or battery. So what do they are? They are the electric current are cells or the battery they are. The SI unit of electric current is ampere. When I talk about the SI unit, it is ampere, which is written as capital A. And the charge which flows. One thing is electric current and the second thing is charge. What kind of charge is flowing? The positive charge, negative charge. That is written as the Coulomb. C, capital C. Now, a good conductor of electricity will be that material through which the electric current will be able to flow easily. And when we talk about the bad conductor, through that the electricity cannot be able to flow easily, like plastic, wood, rubber, wax, and paper. So if we try to try the electricity to get flow to them, they cannot be. And that is the reason that whatever the appliances we have in them, if they have some kind of handles, like if I talk about the utensils also, like when we keep the utensils on the gas stove, what happens? The handles are made up of the plastic or some other material. It is because if they are also made up of the same thing as like the utensils, then we will be able, our hands can burn easily. So that is the reason that this happens. The bad conductor of electricity are also called as insulator. So these things are also called as insulator. So good conductor, aluminum, steel, and gold. Through this, the electricity can be passed easily. And through the insulators, wood, plastic, and rubber, the electric current cannot be passed easily. Now, electric circuit, basically, it's a pathway through which the current flows. Now, this is a proper electric circuit. So if we want that something has to light up or the bulb has to glow, we have to make sure that there should be a cell, there should be a positive negative terminal, wire should be there to connect them. And if it is needed, then a switch also should be there so that we can switch on and off. So an electric circuit is a path through which the current flows. An electric current may be complete electric circuit or incomplete electric circuit. So two type is there. It is a closed circuit or the open circuit. Now, if it is closed circuit, then the current can flow easily. If it is open, then the current will not be able to flow and the bulb does not glow. So you can see in these two pictures, like in this picture, you can see the cell is there, the positive negative terminal are there, and everything is like closed. All the wires are closed from both the direction. and that is why the bulb is glowing. Where here, as here, the switch is being on, right? So that is why the bulb does not glow, because the connection of the wire got disconnected. So in closed circuit, so closed electric circuit, the electric current starts from positive terminal of the source and ends to the negative terminal of the source without any break. So always the charge will flow from positive to the negative direction. The current flows only if the circuit is complete or closed. So if the circuit is complete, then only the current will start flowing, otherwise not. All the elements of the electric current start for functioning. So when it is closed, all the elements will start working together. Whereas in the open circuit, what happened? The electric current starts. So it will start from the positive terminal, but it does not reach that negative terminal because the circuit is broken at some point. So in between, what happened? A gap is there. So because of which the electric current will not be able to pass. In the open circuit, the current does not flow and the element or component of the electric circuit do not work. So since the current does not flow, that is why the element does not work, and that is the reason the particular bulb or the element does not work there. Now, components of electric circuit, what do we need for them? The parts of which constitute an electric circuit are called as elements. So whatever the components are essential to make an electric circuit, they are called as component. Like a cell or battery, connecting wire we need, an appliance like the bulb, fan, heater we need, and we need a switch also. Then symbols we need, symbols for the electric component, electric cell, positive and negative, they will be like this. So the tall one is the positive and the short one is the negative. The electric bulb should be there so as to see whether it is working or not. Switch in off position, switch in on position. So it is, if it is off, then it will be like this. If it is on, then it will be like this. Battery, battery and cell, there is a difference. Like cell will be written as like this, and battery will be two or more cells when joined together, they make the battery. Then wire, it will be, we know it's a straight line. Now, source of electricity is a cell or a battery. So how does the source we will be getting? In the form of battery we will be getting it. Then there may be one or more source of a circuit. So in one circuit we can add one cell also, we can add more than one cell also. It depends upon whatever combination we want. Then connecting wires will be there. So the wires will basically, they will be helping for the charge, or they will be helping for the electric current to flow, like the copper wire, aluminum wire you might have seen. So when you try to open that wires from the appliances, you will be able to see that inside the wire there will be either the copper wire or either the aluminum wire in it. Then we need the appliance, basically, which is a device which uses the current, for example electric bulb, fan or heater. Then we need a key so that we can switch on or switch it off. Now, there are certain effects of electric current: heating effect, lighting effect, magnetic effect, chemical effect. So, with the help of the electric current, what happens? Some of the changes will be there in the appliances or maybe in the magnetic power and all. So, this heating effect, when electric current flows through a conductor, some heat is produced. Like if I talk about the water geyser. So, in the geyser, what happened? The electric current is flowing, and because of this, water gets hot. So it happens because of the heating effect of the circuit. Now, the heating effect will depend upon these three things. First thing, length of the conductor. How much length of the conductor is. Second, thickness of the conductor. So whatever conductor you are using, maybe the copper, maybe the aluminum, what is the thickness of it? And then nature of the material of conductor. What nature it is. Like if you are taking, the nature of the material is rubber. If you are taking rubber as a conductor, it will not work. But if you are taking the copper, it will work. So that is called as the nature of it. In our daily life, there are many applications of heating effect of electric current. So in our day-to-day life, we have so many effects of it. Like the electric iron, the iron for the, pressing the clothes and all, we are using electric heater, room heater. So many electrical appliances, they are based on the heating effect. The wire used for making electric circuit do not normally becomes hot. So we know, like, sometimes it becomes hot, but most of the time the wire which are used does not become hot. Whereas the elements of some electrical appliances become so hot that they're easily visible. And sometimes you might have seen, like especially in the geyser and all, uh, there will be switch. there will be like switch like thing which becomes so hot, and we'll be able to find that these that the geyser has become hot. So element can become so hot, get heated to such a high temperature that it starts glowing. So the normal bulb, it starts glowing because its filament get heated up so easily. Then the short circuit, you might have heard it so many times, like because of the change in the power of the electric current, this short circuit happens. So the short circuit is generally caused due to accidental connection of live wire with the earth wire. So when the live wire and the earth wire, they both are accidentally joined together. So during that time, what happened? This problem will occur. Overloaded electric circuit. A circuit is said to be overloaded when more current passes through the circuit. So sometimes what happen in our home also, what we do, so many wires we join together, and sometimes like in a home we have the less voltage or the connection, but we use more voltage than that. So during that time also it gets overloaded and get heated up and blast. Overloading of circuit occurs due to large current, short circuit, or fluctuation of the voltage. Sometimes the voltage also become high, sometimes also it becomes low and all. So because of this reasons also it happen. Safety fuse or electric fuse. So safety fuse basically you might have seen in your home, like is a kind of box like this box like structure like this you will have there. So this is known as the fuse. So basically it's a safety device which will be using for heating effect of electric current. So it is used to protect electric circuit and electrical appliances against high current. Sometimes if high current has been passed, so what they do, they will be controlling it. They will be automatically working it, and they will be removing all the high current. So high current flows through the circuit because of short circuit or random voltage fluctuation. So when high current flows in a circuit, it is called as overloaded circuit. And to avoid this, what we should do, we should use this fuse. So these fuses are very, very helpful if you want to avoid the short circuit. Different types of the fuse are there. The first one you can see Kit Kat fuse. So the name is given Kit Kat because the structure looks like the Kit Kat only. So it is a combination of the porcelain fuse socket and a carrier. So this white outer part, it is made up of a material called as porcelain. That is why the name is given the porcelain. So porcelain fuse socket. So upper one is this, down one is the socket, and the upper one is a carrier. So what we should do, the upper one we should remove, and the inner one, to the inner part we should insert it. Then cartridge fuses, they, you can see in the picture, they are very, very small in size, and they are also acting as a fuse. So it is made by putting a fuse wire inside a glass tube and connecting its two ends to a metallic caps fitted tightly over the glass tube. So they are made in such a way that inside the glass tube they will be fitted, and both the ends will be connected with the metallic cap. So why they use the metallic cap? So as to avoid the flow of high current in it. So this type of fuses are used to protect sensitive electronic appliances from excessive current. So most of the electrical appliances, if you open them, you can see that inside these kind of the fuse will be present, which are known as a cartridge fuse. And coming to the most important nowadays, which we use in our home also, is the miniature circuit breaker, which is called as MCB. So wherever you have, the box of that MCB, you can go and see like a button will be there like this. Automatically, when the current flows is very high, what happened? Automatically, the switch will come down, and your appliances will be safe. So that is why MCB is being used. That automatically, when the current is high, what do? They will put the button down by themselves, and because of which the electrical appliances be safe. If this MCB is not there in our home, then if in case the high current is flowing. In that case, all the electrical appliances can have the blast or they can get destroyed. So that is why these MCBs are very important nowadays. So MCB is also a type of safety device which is connected in the electric circuit. Unlike in fuse, the MCB stops the flow of current by simply turning off. So automatically they will be turning off. To continue the current flow, what has to turn on? Now, for automatically it can get off, but if we want it again, we have to switch it on. We have to do it. Automatically it does not turn on. And now, for example, I have turned on now. Now again, if the current is high, again automatically it will get fall down. It will get on the off position. So I should understand that if I have on it again, if it is going down again, if it is getting off again, it means still the current is high. So until unless it is not going off by itself, we should understand it. So this was a heating effect. Now the next one is magnetic effect. Basically, it's working on the basis of the electromagnet. So in 1820, Danish scientist Hans Christian Ørsted discovered that the electric current has magnetic effect. The relationship between electricity and the magnet is known as electromagnetism. So what we should do, a coil of the nail, we should take a wire, we should take, and when we connect both of the end of the wire to a cell, the current starts flowing to it, or it starts as acting as a magnet. You might have seen the electric bells are there, right, in the school. So how they work? They work on this electromagnetism only. So they work on electromagnetism. In this, what do they have? They have the electric current also, they have the iron also, they have the magnet also. So because of which it starts working. So you can see the principle how the electric bell works. It works on the principle of electromagnetism. Electromagnetism means electricity plus the magnet. Construction and working, it consists of soft iron armature mounted on a springy metal strip placed in front of a U-shaped electromagnet. So this is the like basically proper connection of it. A switch is here, a iron strip is here, a contact screw, hammer is there, coil of wire, electromagnet. So as soon as what we are doing, we are switching it on, the wire, from the wire, the it goes to the signal terminal, positive terminal, from the positive to negative, then again to the positive to negative. Through that, the current will start flowing to the coil of wire, and as soon as the current reaches to this iron strip, it starts banging. Why it starts banging? Because it fall down and it makes them to start here. So this hammer will start because of the iron strip. What happened? The hammer starts banging, 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 gonging, gonging will happen. And as soon as again now if we will change the switch position, what happened? Whatever the process was happening, it starts coming back to the normal process, normal step. So electromagnet is wound on a insulated copper wire of a large number of turns. One end on the insulated copper wire is connected to T1 of the cell and the other end on the metal strip. The metal strips makes contact with one adjustable contact screw at contact point. A hammer is made up of steel and it is attached to the armature. It also consists of a gong, which is made up of the brass. When the bell operates, the hammer repeatedly strikes against the gong and produces the sound. So continuously what is happening? They'll start producing the sound. Uses of electromagnet, they are used in many electrical appliances like the electric motor, electric fan, electric bells. They are also used as the electric generator. They are used in the television. They are used in the magnetic separation of the iron ores. They are used in the clinical appliances to remove magnetic bodies like the iron fillings from the patient body's part. And for making the permanent magnet also this will be used. So, and this is like about the electric current and its effects. Anything like you have any doubt?
No.
So this chapter is very, very important, not only for the grade 7, for your upcoming years also, like for the grade 8 also, for the grade 9 also. These chapters are there, for the long time. So grade 10 also you have a big, big chapter of this. And then grade 11 also you have. So every year you are going to learn this chapter. So now just open the resources. There you will be finding the questions with the name electric current. The foundation question will be there. Electric current and its effects, foundation. Have you got it?
Yes, ma'am.
Okay. So start doing from question number 1.
Ma'am, how many questions should we need to do?
Question number 1 to 10, so that we will be discussing it. And then after that, 11 to.
Okay, ma'am. Ma'am, Varshit completed.
Okay.
Ma'am, Anubhav completed.
Okay.
Ma'am, Yashwant completed.
Okay, just give me 1 minute. So we'll start discussing this now. Let me share the screen. Okay, so what should start with question number 1? I'm sharing my screen. Yes, Varshit, start with question number 1.
Which one of the following electric component is used as a safety device in electric circuits? Ma'am, the answer is D, fuse.
Correct. So the correct answer is B. Good. Yes, Ashwant. Question number 2.
The device used to prevent the flow of access current in the circuit is fuse, ma'am.
Correct. It is fuse. So the flow of excess current will be stopped by or prevented by the fuse. Anubhav, question number 3.
Yes, ma'am. In question number 3, which of the following is not a circuit element? So I think it is potential difference.
Yeah, potential difference is not at all required for the circuit to make. So we require the voltmeter, we require the resistor, we require a battery, but we do not require a potential difference for it. Varshit, question number 4.
Which of the following is symbol of a bulb? Ma'am, I think it's D.
Yeah, so D is a symbol of a bulb. Correct. Question number 5, Yashwant.
Why is electricity return usually covered with a layer of plastic? Ma'am, my opinion is C, ma'am.
Correct. So to make it safe, the electric wires are covered by a plastic. Question number 6, Anubhav.
Yes, my magnetic effect of current was discovered by option B.
Yeah. Option B, Hans Christian or as Alsted. So he
Yes,
discovered the magnetic effect of current.
yes,
Question
ma'am.
number 7, Varshit.
Which of the following statements regarding an electromagnet is not true? I think it's option D.
Yeah. So the option D is not true that it is a permanent magnet. So electromagnet is not a permanent magnet. So whenever we remove the switch or key, it stops working. So it is not a permanent magnet. Question number 8, Yashwant.
Which one of the following switch, if opened, will cause the light bulb to stop glowing in the given circuit? Ma'am, it's P, ma'am.
Hmm.
A.
Yeah. So P, if we remove the P, then what happened? The bulb does not glow. Anubhav, question number 9.
Question number 9. Why is electrical wiring usually made from copper and not silver? So I think option C, copper is less expensive.
Right. So if we use the copper, we use the silver for making the wire, it becomes so expensive for us. So that is why the copper is used. So it is less expensive in nature. Yes, Varshit, question number 10.
The shorter, thicker vertical line in the symbol of a cell represents, I think the negative terminal. Option B.
Yeah, correct. Correct, Varshit. It is like short line is known as the negative terminal. Correct. Now start doing question number 11 onwards, 11 to 20.
Ma'am, Varshit completed.
Okay.
Anubhav completed.
Okay.
Ma'am, you should complete it.
Okay. Okay. Give me a minute. I'll show. So question number 11. Yes, Anubhav, start with question number 11.
Yes, ma'am. Which of these appliances does not use electromagnet? No, I think it is washing machine.
Appliances does not use an electromagnet. They're talking about that is room heater. So for the refrigerator also we have electric bell, also we have washing machine, also have the magnet, and because of the magnet only they are able to attract the dust. Okay, so room heater does not have the magnet.
Yes, ma'am.
Question number 12, Yashwant.
Which of the following does not belong to the group formed by the others? Ma'am, D, ma'am.
Which of the following does not belong to group from others? No, it is C, wooden ruler. So wooden ruler is what? It is an electrical insulator, whereas the others, they are the conductor. Okay.
Okay.
So wooden ruler is the insulator, whereas the remaining three are what? They are the conductor. Question number 13, Varshit.
Iron is used for making electromagnet, not steel, nickel, cobalt, etc. Because, ma'am, I think option A.
Iron is used for making electromagnet, not steel, nickel, cobalt. Okay. Why we are using the iron but not using the steel for making the electromagnet? It is because of C. Because when current is switched off in the coil of electromagnet made of iron, iron loses all its magnetism quickly. So as soon as what we do, we switch it off, the iron will not be getting the power to work ahead. Sometimes what happen now, if we are making the electromagnet with the help of steel, nickel and all, what happened if we have switched it off also? In that case also the current, what happen, current will keep on flowing. That is why we do not use the steel, nickel, because if it is in switch position also, what happen, the current will be keep on flowing. So iron will not allow, after switch it off, the current does not flow with the iron. That is why we used it. Question number 14, Anubhav.
Question number 14. If you place a compass near a current carrying wire, it will, I think, get deflected.
Yeah, so it get deflected. So the correct answer is A. 15th, Yashwant.
A current carrier carrying a
Carrying
coil
coil.
of an insulator wire wrapped around a piece of soft iron becomes B, ma'am, an
Yeah, electromagnet. Yes, correct. So what will happen if we are covering or carrying current coil with a wire? Then what happened? It becomes a electromagnet. Question number 16, Varshit.
Which of the following is not a source of electric current? Ma'am, I think option B, dry cell.
No. For the electric current, not a source of electric current, electromagnet. So basically, car is needed, battery is needed, cell is needed, dry cell is needed, cell is needed. But electromagnet is not needed as a source. Electromagnet is an extra add-on to it, not a main part of it.
Okay.
Question number 17 and above.
Mark out the correct statement, ma'am. I think it is option A.
Yeah. So it is A, fuses and MCB are safety devices. Yashwant 18.
Which of the following is the best conductor of electricity, ma'am? Ma'am, silver. A.
Correct. So A, silver. Correct. 19th, Varshit.
Electricians wear rubber gloves because it is, ma'am, option C, an insulator.
Very good. It is option C. It is act as an insulator. Anubhav, the 20th one.
Yes, ma'am. The electric bill makes use of, ma'am. I think it is option B. Large segment electromagnet.
Question number. No, it is electric bell is made up of U-shaped electromagnet. So if it is U-shaped, then only we can push the button, right? If it is like a bar magnet, the push button will not work. We cannot turn it off and on. So that is why it is made up of the U-shaped.
Okay, ma'am.
Okay. Now go with the question number 21 to 30. Angela, turn on your video also.
Ma'am, Varshit completed.
Okay.
Ma'am, Anubhav completed.
Okay. Okay, Anubhav, start with question number 21.
Yes, ma'am. In question number 21, the thin wire inside a bulb which glows when electric current is passed through it is filament.
Correct. It is filament. Question number 22, Yashwant.
Okay. The bulb is in an electrical circuit glows are because of, ma'am, my personal option is B, ma'am.
Correct. It is B. So the bulb will be glowing because of the heat effect of current. Varshit, question number 23.
A battery is a combination of, ma'am, I think option B.
Yeah, battery is a combination of two or more cells. Correct. Question number 24, Anubhav.
Yes, ma'am. Key or switch in a circuit is placed, ma'am. I think it is option D. Not sure, ma'am.
Key and the switch we can place anywhere in the circuit. So the correct answer is C.
No, I have also
So it
think
does
that.
not. So it does not matter like where the key or where the switch is. 25, question number, Yashwant.
Okay, ma'am.
When the two terminals of a cell are connected directly with a wire, then, and my personal choice is E, ma'am. I don't.
It's B. The chemical get used up very fast. So when we are connecting directly with the wire, then what happens? They are getting up used easily. Question number 26, Varshit.
Which of the following keys are true about CFLs? Ma'am, I think option A.
Option C. So CFL basically they reduce power consumption. They does not use much of electric current, and they can be fixed in ordinary bulb holders. So normal bulb holder, we can fix the CFL bulbs. Question number 27, Anubhav.
Yes, ma'am. In question number 27, an electric heater is used by us to convert electrical energy into heat energy.
Correct. It will be converted into the heat energy. 28, Yashwant.
Ma'am, wait. Okay. The necessary requirements for a fuse wire is that it should be, ma'am, B, ma'am. I don't think so.
A. So what do we need is a conductor with low melting point. So if we want that fuse should be there with a proper thing, then the conductor should be with a low melting point. Okay, it is A. Varshit, question number 29.
Which mark is necessary on electric appliances? Ma'am, I think it's option B.
It is A. You can see any of the appliances. When you see any of the appliances, you will be able to see the mark ISI. It will be marked there ISI. Anubhav, question number 30.
Yes, ma'am. SI unit of charge is coulomb.
Correct. The SI unit of the charge is a coulomb. Fine. So we are done with the level 1. Level 2 question we'll be doing in the next week. For coming Sunday, you have the objective test. And The
All
chapter
India
will be
test
physical
series.
and chemical changes. Yeah, all India test series also you have. Plus in the all India test series, the chapter is, what was
Nutrition
the chapter there? Nutrition in plants, I guess. Huh.
and
Nutrition in
practical
plants, it is there, and then so prepare well for it. And for maths, it is lines and angles. Okay, practical geometry is being changed to lines and angles. I hope you have seen that message in the group, right? AITS group.
Yes, ma'am.
I
Okay,
have not
so
seen.
what if just see it in the group? I think you might have added yourself in the all India test series group. There I have posted the syllabus, revised syllabus. So every week on Monday, the syllabus will be posted there, and accordingly, then you can prepare for the 5 days or 6 days, whatever are there. Okay, and Sunday from morning 8 o'clock till Monday morning 8 o'clock, you can attend anytime whenever you feel like you have to attend. But it is a time based, so automatically within 20 minutes it will get submitted automatically. Fine, so you have to be careful because 20 questions are there in the maths, 20 are there in the science. And science, anyhow, somewhere you will be able to complete within 20 minutes, but for maths, you need to solve it, right? So you have to increase your speed at the same time for it. Okay?
Yes, ma'am.
Okay, children, then all the very best.
Thank you, ma'am. Bye, ma'am.
Okay,
Thank you,
welcome. Bye
ma'am.
bye.
Bye, ma'am.
Bye bye.